Hi, welcome to my presentation. I am Dinesh Phuyal, a graduate student. Today I will be talking about effect of tree planting density and nutrient application on SLB affected grapefruit, as it is very obvious that SLB has been a serious problem for citrus production in major citrus producing states such as California, Texas, Florida, and Arizona. In Florida, over 95% trees in the commercial groves are affected with this insidious disease. And the trees affected with SLB produces fewer number of fruits, with fruit having inferior juice quality. So far, we don't have a complete cure for this disease. Management of this disease relies on several approaches. One of the approaches is high density planting. It is very clear that the SLB affected trees has higher production cost but lower yield. The high density planting resulted greater yield in mandarin, sweet oranges, and limes in area basis without affecting the fruit quality. However, there are limited information available for grapefruit. Another important approach is nutritional treatment by soil. The SLV affected tree shows deficiency symptoms of some major macronutrients such as phosphorus, calcium, magnesium, and some major micronutrients such as manganese, zinc, and iron. We need to supply those nutrients. The problem is Florida's sandy soil, which has poor water and nutrient holding capacity. Also, the SLV affected trees has poor root architecture, which has difficulty to obtain micronutrients from the soil. Past studies shows that the ground application of 4 times of manganese can increase the CT value. Here the CT value is an indication of concentration of bacterial DNA. Higher the CT value, lower will be the concentration of bacterial DNA. Another important approach is foliar application of micronutrients. The foliar application of micronutrients is important for perennial fruit crop, especially when the nutrient demand is high, such as flowering and fruit setting stage, and when the soil condition is not good for the nutrient uptake. Studies shows that the application of foliar micronutrients can increase the leaf nutrient concentration, can increase the yield when applied alone or with combination with other substances such as hormones and pesticides, and can decrease the disease symptoms. There are limited information available about the effect of foliar application of micronutrients in SLV affected grapefruit. So in order to address those problems, we conducted a study with 3 major objectives. Our first objective is to evaluate the effect of tree planting density on SLV affected grapefruit. The 3 planting densities we tested were low density single row, which resulted 300 trees per hectare, high density single row, which resulted 440 trees per hectare, and high density double row, which is also double high density planting, which resulted 975 trees per hectare. So in order to establish high density planting in Florida sandy soil, we needed to come up with a unique approach because of the waterlogged condition. So our grove configuration was in triangular shape, in which 2.7 by 1.5 by 1 meter resulted 975 trees per hectare. So the trees were planted in raised bed of 50 feet length. Our second objective is to evaluate the effect of high amount of micronutrients and magnesium applied to soil to assess tree growth, fruit yield, and fruit quality parameters and plant physiology parameters. The nutrients were the soil application of micronutrients were applied in February, July, and October. Our third objective is to assess to find the optimum combination of foliar application of micronutrients to assess its effect in plant growth, tree health, fruit yield, fruit quality, and plant physiology parameters. The foliar application of micronutrients were applied in March, May, and September. Here is an overview of main plot. So our main plot, we had 2 different control release fertilizers. In the year 2018-19, the control release formulation 1 had higher micronutrients compared to control release formulation 2. In the year 2019-20, we adjusted the nutrients. So the control release formulation 1 had 2 times manganese plus 2.5 times recommended rate of micronutrients. Here the recommended rate means recommended rate made by University of Florida College of Agriculture and Life Science. And CRF2 had 1 times recommended rate of micronutrients. Our subplot was 3 different planting densities, which I already described in objectives. Our subplot was combination of boron, manganese, and zinc for the application of micronutrients. 0 being control, 1.5, 3, and 6 times application. The IFS recommended nutrients for grapefruit is boron 0.28 kilogram per hectare, zinc 5.6 kilogram per hectare, and manganese 4.2 kilogram per hectare. In order to evaluate our objectives, we took a couple of measurements, tree growth measurements in June and December, fruit yield in January, fruit quality right after fruit harvesting, leaf gas exchange in April, soil nutrient analysis before soil fertilization and before rainy season in February, soil nutrient sampling in August, and SLB diagnostic by real-time quantitative polymerase chain reaction in April. On top of that, we had 48 soil moisture sensor installed in the field. The soil moisture sensor were programmed to collect data in every 15 minutes. It was connected to a data logger. It was installed 2 feet away from the main trunk, 6 inches below the soil surface. As you can see, the graphs generated by soil moisture sensor during the experimental period. Now the results. Here the x-axis represents 2 different application of control release fertilizers. The black represents the formulation with higher rates of micronutrients, sulfur coated higher rates of micronutrients, and red represents lower rate or IFS recommended rates of micronutrients. The higher rates of sulfur coated micronutrients fertilizer actually increase the canopy growth in both seasons. 10% increase in 18-19 and 8% increase in 19-20. Again, here the x-axis represents the application of control release fertilizer and y-axis represents fruit yield in left, fruit number of fruits in left, and fruit qualities in right. So as you can see, the IFS recommended control release formulation actually increased the number of fruit. However, it decreased soluble solid content and ratio. So it is an interesting, what we can conclude from this graph and our previous graph is that the application of higher rates of micronutrients actually increases the canopy growth with the expense of fruit yield. Here the x-axis represents 2 different control release formulation and y-axis represents plant physiology. The application of higher rates of micronutrients actually enhance the plant physiology, which could have improved the canopy growth. Here the x-axis again represents 2 different control release formulations. On right, y-axis represents soil magnesium concentration. On left, y-axis represents soil pH. The soil pH was in optimum range for grapefruit in Florida sandy soil, which was recommended 5.5 to 6.5. Here we observe an interesting result with magnesium. Even though we applied more magnesium with control release formulation 1, we observed less magnesium. Could be because of the soil pH. So what we observe from past studies in other crops, if the soil pH decreases below 7, the soil magnesium concentration decreases. So it gives an interesting message that it is not always necessary that we apply more nutrients. The soil should have more available nutrients. The soil pH plays important factor to adjust the available soil nutrients. Here the x-axis represents 3 planting densities and y-axis represents canopy growth on top and trunk diameter on bottom. The double row high density planting represented by red bar, single row high density planting represented by blue bar, and yellow represents single row low density planting. As you can see, with increase in planting density, the canopy growth and trunk diameter decreases. The canopy volume decreased 37% and the trunk diameter decreased 17% in double row high density planting compared to single row low density planting. Here again the x-axis represents 3 different planting density and y-axis represents fruit yield per unit area. The double row high density planting resulted 193% higher yield compared to single row low density planting in the year 2018-19 and 130% higher yield compared to single row low density planting in the year 1920. It gives a clear message that the double row high density planting has an advantage to produce higher yield. Here the x-axis again represents 3 different planting densities and y-axis represents fruit quality. So the double row high density planting resulted 5% more soluble solid and 13% more acidic juice. It could be because for the in double low high density planting, due to the competition for water resources, more soluble solid deposited and the juice were acidic in nature. Here the x-axis again represents 3 different planting densities and y-axis represents plant physiology. So what we can observe here, the double row high density planting has 21% less photosynthesis compared to single row high density planting, and single row low density planting and single row high density planting has an average 16% higher for stomatal conductance compared to double row high density planting, possibly because the competition for solar radiation and resources was higher in double row high density planting, which could have impaired the plant physiology. Here the x-axis represents 3 different planting densities and y-axis represents yield of solids. The double row high density planting has an advantage to produce high solids. As you can see in the year 1920, double row high density planting resulted 200% more soluble yield of solids per unit area compared to single row low density planting. Here the x-axis represents 4 different foliar applications of micronutrients, 0 being control represented by black bar and yellow being 6 times application represented by yellow bar. And the top graphs represents yield per tree and the bottom graphs represents yield per unit area. With the increase in foliar application of micronutrients, the yield per unit area as well as yield per unit tree decreased in both years. Here the x-axis represents 4 foliar micronutrients and y-axis represents plant physiology. With the increase in foliar micronutrients, plant physiology decreases. Here the x-axis represents 4 different combinations of foliar application of micronutrients and y-axis represents plant leaf nutrient concentration. And the green lines represents optimal level of nutrients. So with the increase in foliar application of micronutrients, the leaf nutrient concentration increased except for boron in the year 1920. All the nutrient level with the application of 1.5 times, 3 times and 6 times exceeded the optimum range, which could have decreased the fruit yield, which I talked in previous slides, and as well as plant physiology. Here the x-axis represents again 4 different foliar applications of micronutrients. Y-axis on right represents potassium concentration and y-axis on left represents copper concentration. So the copper concentration decrease with increase in foliar application of micronutrients could be due to the antagonistic effect of zinc. And potassium concentration increase could be due to the effect of boron alone or combination of boron with zinc, as it was observed in previous studies. The soil manganese concentration and soil zinc concentration increase with increase in foliar application of micronutrients could be because the foliar space solution might have fell into the ground. Also, we observe some interesting interaction in which the fruit produced from single row low density planting were larger compared to other treatments. Also, the leaf nutrient concentration was higher in control risk formulation 1. It is obvious because we applied more amount of micronutrients in control risk formulation 1. So the conclusion of our studies is that the CT value was unaffected with the application of treatments. Higher amount of soil application improved the plant physiology, improved the canopy growth with the expense of fruit yield. High density planting resulted in smaller trunk diameter and canopy volume, but resulted greater yield per unit area with high soluble solids. Fruit yield photosynthesis, stomatal conductance decreased with increase in foliar application of micronutrients, but increased leaf nutrient concentration. So the ultimate conclusion is high density planting could be a promising way to increase fruit yield per unit area, but in order to recommend it for commercial cultivation, it needs to be done for more years. I would like to thank all the people who helped me in this project. Thank you for watching my presentation. If you have any questions, please send me an email. I'll be happy to answer it. Thanks a lot.